In today's podcast, I'd like to talk about AC circuits. Essentially, I want to introduce two new elements, capacitors and inductors. These are the first elements that are non-ohmic. So we described ohmic materials as obeyed Ohm's law. Delta V equals the current times the resistance. And so the capacitor and inductor are going to be our first two elements that don't obey this rule. So let's look at a little bit about the capacitors and inductors and the physics behind them. So here's capacitors. Capacitors, the purpose is they store energy in an electric field and in fact actually store charge on these plates. So how do you make them? You have two metal plates, you connect wires to each of those plates, and that essentially is a conductor. Now you can buy lots of fancy products, you can put dielectrics in between, but air works just fine. And you have these two plates, you put charge on the plate, and that's a capacitor. The symbol is two parallel lines like this. And this is basically how it works. We push charge onto one side. So we move some charge with some kind of power supply, put charge on that side. Well, that charge sets up an electric field. And on this other side of the capacitor, you have it's neutral, you have positive and negatives. Well, the positive charge repels the positive and attracts the negative. So we repel positive away, off, and we keep a negative charge here. So at the end of the day, the net charge on this capacitor is essentially zero. Okay, and so it's like current passes through the capacitor, but that's not really true. We put positive charge here, and that pushes the positive charge away, leaving the negative charge. And as we push more and more charge on there, we can build charge up. It gets more and more difficult to put charge on that plate. And at the end, or at any time, we've pushed a certain amount of charge, and there's plus Q on one side, minus Q on the other side. Basically, the relationship, the potential across the capacitor is given by the charge on the capacitor, plus Q or minus Q, divided by the capacitance. And capacitance is just a function of what's the size of the capacitor, what's the dielectric between them, and so on. And essentially, the capacitance measures what's the size of the bucket. Are we trying to put charge in a cup, or are we trying to put charge in a very large bucket? Okay, so that's the basic capacitor. Let's look at the inductor. The inductor, the purpose is to store energy in a magnetic field. Okay, and essentially it sort of resists changes in current. How do we construct an inductor? Well, we essentially just make a coil, right? We have some wire, we wind it into a coil, and there's an inductor. Now typically we wind that coil, we wind many loops in an inductor. Okay, but the idea is the same. We have some loop. So the symbol is sort of this squiggly line that sort of represents this is a series of coils. So what's the basic physics? Well, if you remember from your introductory physics, current passing through a loop or a wire in general will produce a magnetic field. So in this case, if we have current moving around the loop, we'll generate a magnetic field that points from left to right inside that loop. So the current produces the magnetic field. So if we sit there and then if we decide, hey, we're going to change the current, so we're going to increase the current, well then that'll increase the magnetic field. And so basically Faraday's law says we're going to induce some kind of a magnetic field in response to this change. And so a changing magnetic field, delta B, will induce a magnetic field and an EMF, which sort of opposes the change. And so that's represented right here. And essentially the potential across the inductor is given by the inductance, which again is just some property of how did you make the inductor, times the time rate of change of the current. And essentially the overall thing is the inductor sort of resists changes in current, tries to keep the circuit doing what it was doing before. So that ends this podcast. In the next podcast, I'll talk a little bit about what happens when we put these elements into a circuit with a battery.